Have 3 computers that show at random from an old inventory of Dell computers in a bookstore display. Assume the same number of each brand of computers in stock. Construct a sample space for all the possible choices. Okay, so we need to include a sample space for Apple or Dell, but it's up to 3 choices. So this is going to look something like when we had like 3 siblings. Okay, so it's going to be Apple, Dell, and you just kind of make the branches for 3 choices. And then we're going to make the sample space. We're going to create a list of the sample space. So that's going to be, it goes like this, right? So our sample space is going to be A, D, 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 and then D. So our N equals 8. Remember, that's a count. So it says find the probability that all 3 will be Apple. So this is going to be 1 out of 8. Exactly 2 will be Dell's. This will be 3 out of 8. And at least 1 will be an Apple. This is 7 out of 8. Construct the sample space of the probability experiment where a coin is flipped and a 10-sided die is rolled. So we need to create the sample space on this right here. So again, it's in set notation. And we're going to do heads and then 1 through 10, and then tails and then 1 through 10. So this is the entire sample space. You're going to have to create the sample space. Luckily on the test, the sample space is not more than like 10 elements. So it's going to be heads 1, heads 2, H3. It says, construct the sample space of the probability experiment where a coin is flipped and a 10-sided die is rolled. So all you're doing here is making these, the sample set. So it's like heads and then the number, because the die has numbers 1 through 10. And then it goes on with heads and then it's tails and then the number. Remember, because you're rolling both simultaneously. So that means your sample size, or N, is equal to 20. So it says there's a tail on the coin and an odd number on the die. That's going to be 5 out of 20 because you have to look at all the odd numbers. 1, 2, 3, 4, 5. So that's going to be 5 out of 20 because it's the entire sample. So that's going to be equal to 1/4. And says there's a tail on the coin and the number is prime on the die. Prime is only 2, 3, 5, and 7. We don't include the number 1 as prime. So in this case, it's going to be 4 out of 20 or 1/5. And then the last one, there's a tail on the coin and the number is less than 7 on the die. So tails and the number is less than 7. So that's going to be 1, 2, 3, 4, 5, 6. And that's going to be 6 over 20 or 3 out of 10. Grabs a latte before class so she can stay awake through her morning lecture. She has a $1 bill, 5, and a 10. So she has, let's see. So Ebony has a 1, a 5, or a 10. We're going to make a tree chart out of this. She pulls out 1 and looks at it, but then puts it back. So she's doing this with replacement. Distracted by a flyer of the new campus organization, she randomly hands a bill from her wallet to the clerk. Construct a sample space. So these are our options, and then we're just going to go from there. If we have a $1 bill initially for the first grab, and then she replaces it so she can pull out a second bill. So she gets either a 1, a 5, or a 10. So the combination here is 1, 1, 1, 5, 1, 10. And then she has a 5 initially. And then suppose the second time she grabs something, it's a 1, a 5, or a 10. It's going to be 1, 5, 5, 5, and then a 5, 10. And then initially she could have grabbed a 1. And then the second time she goes to grab bills, a 1, a 5, or a 10. And then our combination is going to be 10, 1, 10, 5, 10, 10. So both bills have the same value. The probability of that is going to be a 1, 1, 5, 5, 10, 10. So that's going to be 3 out of 9. Because our n here equals 9. The second bill is smaller than the first bill. That would be a 5, 1, a 10, 1, or 10, 5. So that's going to be 3 out of 9. You want to make sure that you're simplifying these. You can just simplify that in your calculator. The value of each of the two bills is even. So that's going to be a 10, 10, 1 out of 9. The exact value, or the value of exactly one of the bills is odd. That's going to be a 1, 10, 5, 10, 10, 1, or 10, 5. So it's going to be 4 out of 9. And then the sum of the values of the bills is less than $5. That's only going to be a 1, 1. So that's going to be 1 out of 9. One of the game, the contestants pick a single card from a standard deck, and payouts are based on the card chosen. Express your answers as reduced fractions. Find the probability of the card picked. Okay, so we're going to do a basic deck, and we're going to do a deck of 52. You need to see page 163. So it says a 10 of clubs. There's only one of those, so it's going to be 1 out of 52. A black 10, so that's going to be either a 10 of spades or a 10 of clubs, so that's going to be 2 out of 52 or 126. A club, a diamond, or a spade. You have 13 of each suit. So it's 13 times 3, 39. So 13 club, 13 diamond, 13 spades. It's going to be 39 out of 52, which is 3/4. Let's see. A2 or an ace. So there's 4 2s and 4 aces. So that's going to be 8 out of 52. And that's going to be 2 out of 13. A queen. There's only 4 queens. So that's 4 out of 52. That's going to be 1/13. A club and a 10. So that's going to be a 10 that's a club. That's going to be 1 out of 52. A red card and a 3. So it's 26 reds. And then there's, or 3. So you have to do the 2 3s that are black, and you have to do the 2 3s that are red. No, a red card or 3. Oh, it's both of them together. So it's going to be the 2 3s that are black. So it's 28 out of 52, which is 7 out of 13. And then a black card is going to be 1/2.